We start this course looking at types of numbers, and it might seem a little strange to be talking about something so simple, but there will be questions where they want to know, are they real, are the roots rational? You need to be able to answer that question. So we're going to do a quick review. The first one that we look at is integers. So integers are whole numbers, and that includes positive, negative, and 0. So you're looking at -5, 3, 0, and anything either side. Next, we look at rational numbers. Rational numbers can be written as a fraction a over b, where a and b are integers. So, for example, we have things like 2/5, or we might have -3. We could have a decimal terminating or recurring. We'll look later at how we can turn a recurring decimal into a fraction as well. But the defining feature here is that the a and the b, the numerator and the denominator, are integers. So if rational numbers can be written as a fraction, irrational numbers, the opposite, cannot. Two of the most common that you'll see in this course, there's an endless amount, but the two most common that we're going to look at are pi, because pi is a decimal that continues on forever without repetition. There is no fraction that I can write that exactly equals to pi. The other most common one is √2. You can type that into your calculator and get an approximation, but it's not going to be an exact number. It's another decimal that continues on without repeating the same pattern. So what I want you to do is to categorize these numbers. So make your columns rational, irrational, and we'll go through in just a moment. Pause the recording, start playing it again once you're done. So we've got rational and we have irrational. Hopefully, looking at that list, √5, if you type that into your calculator, if you're not sure, type it in and see if you can find a pattern. √5 is an irrational number. There's no fraction that I can write that is exactly equal to √5. Okay, 1.7 repeater though is, because 7 repeater can be written as a fraction. 2/3, well that's already a fraction where the 2 and the 3 are integers, so obviously that's a rational number. Square root of 100. Now don't assume anything with a square root is irrational. The square root of 100 is 10. So therefore the root of 100 is a rational number. Pi over 3. Now think very carefully about that one. Is the pi an integer? It's not. Pi over 3 is an irrational number. And lastly, we've got a decimal, -2.831. Again, is rational. So the next thing that we need to go over is order of operations. Now we're going to do this very quickly, but it is something that you guys need to understand and have a really good conceptual understanding of, because if you get it wrong, then everything you do after that point is going to make no sense at all. So hopefully we're all familiar that the first thing we do, brackets. Now one that's not often addressed when this is first taught to you in primary school is indices. Sometimes you'll hear it called exponents, means the same thing, so anything with a power. Multiplication and division, from left to right, it is not always multiplication before division. It is whichever of those is on the left. And last is addition and subtraction, again from left to right. Make sure you do them in the right order or your answers aren't going to make sense. So here's 3 questions. As you can see, the only thing that's changed is the brackets. I want you to work these out, but as a nice little challenge, I want you to do it without your calculator, because when we have to start thinking about order of operations algebraically, we're not going to be able to rely on the calculator to figure that out for us. So give it a go. We'll check the answers next lesson. Now the last thing we need to look at before we can get started on the first exercise is rounding off. Hopefully this is something we're all really good at by now. You don't want to be losing marks on something as simple as rounding off. But one piece of advice, guys, do not round off your answer until you get to the very last step. Okay? If you start rounding off early in the question, then your final answer is going to have rounding errors and you will lose marks. Rounding off is something we only ever do at the last point of our calculations. So when we're given an example, in this case round 0.63821, correct to one decimal place. So we're going to keep the first decimal place, we're keeping the 6. So the number that we need to look at is the one after it, in this case it's the 3. If the number after the point where we're rounding off is less than 5, which it is in this case, we round down to 0.6. If we were asked to round 2 decimal places, then we would need to keep the 6 and the 3, and the number that we would need to consider would be the 8. So if the next number is 5 or more, we round up. So in this case, it would round off to 0.64. That's everything you need to be able to start the first exercise, 1.1. It's on page 7. You're welcome to have a look, and we'll work through it next lesson. See you then.